So today we're going to do part 2 of section 3.1. Example 4. An elevator has a maximum load of 2,400 pounds. If the weight of one robot is 180 pounds, what's the maximum number of robots that can safely ride the elevator? So, what we're looking for in this problem is number of robots. So we're going to let the number of robots is X. Well, then we have 180X, because that'll give us the total weight of the robots. That has to be less than or equal to 2,400 pounds, since that's the maximum load capacity. So we can be less than it, we can be equal to it, we just can't be greater than it. Now we can go through and solve for X. So we divide by 180. Divide by 180. So X is less than or equal to 2,400 divided by 180. Now here we can reduce. For example, I can cancel a 0 out. So we get that this is equal to 240 divided by 180. Well, I know 6 goes into 24 and 6 goes into 18, so I'm going to divide the top and bottom both by 6. We get 40 over 3. Now, 43 does not go into 40, so that means this is not a whole number. So in order to find the number of robots, because you can only have a whole number of robots, we need to do the long division. So 40 divided by 3. So 3 goes into 4 once. 1 times 3 is 3. 4 minus 3 is 1. Drop the 0. We get 13. 3 times 3 is 9. We get 1. Now, I could find the decimal, but the decimal doesn't matter because X has to be less than or equal to this decimal. And since X has to be a whole number, that means X is 13 robots. That's the maximum number of robots. And they'll actually be under the weight limit at 13 robots. Example 5. Casey charges $30 to mow neighbors' lawns. How many lawns must they mow next summer if their goal is to earn at least $1,000? So what we're looking for is how many lawns. So that means the number of lawns mowed is X in this problem. And then just like with the robot, we're going to take that $30, because it's $30 per lawn, times X. And we want at least $1,000. At least means greater than or equal to 1,000. Now, to solve for X, I divide by 30. Divide by 30. So X is greater than or equal to 1,000 over 30. Again, I can reduce a 0 on both those numbers, and we get 100 over 3. And just like in example 4, because we're talking about the number of lawns mowed, we need a whole number of lawns. So I'm going to take 100 divided by 3. Now, with long division, instead of going one digit at a time, you can go multiple digits at a time. For example, I know 3 goes into 10 3 times, but I also know that 3 goes into 100 33 times. So 33 times 3 would be 99. Subtract, we get a 1. And just like with the robots, I don't care what the decimal is because I only want a whole number. But this time, I have to be greater than or equal to that number. So to be greater than or equal to that, whatever that decimal is, I actually have to round up to the next whole number. So X is 34 lawns. And that's how we do example 5. Example 6. Jenna is planning a resort vacation with 3 of her friends. It'll cost her $279 for airfare, $300 for food and entertainment, and $65 per day for her share of the hotel. She has $550 saved for her vacation and can earn $25 per hour as an assistant to her aunt's photography studio, helping with senior picture sessions. How many hours must she work in order to have enough money for a 5-day vacation? Why should you round up to the nearest hour? And then how long of a hotel stay can she afford if she works 80 hours at the studio? Why should you round down to the nearest day? Okay, so for the first one, how many hours can she work to have enough for a 5-day vacation? So before I can find the number of hours, actually, let's write that down because that's what we're looking for is hours. So let me do this. A, B. So for A, the number of hours worked is X. So before we can find that, though, we have to find how much does a 5-day vacation cost. Well, so the total cost will equal 279 plus 300 plus 65 times 5. What does that equal? $904. So she needs a total of $904. But she already has $550 saved up. So how much more is needed equals 904 minus 550. $354. Now that we know that, we can say, well, she makes $25 per hour. So that would be 25x. And because I need $354, that's the minimum I need, we're going to say is greater than or equal to 354. So we divide by 25, divide by 25. We get 354 divided by 25. And just because X is the number of hours worked, a decimal, I guess, would be okay, but most people, when they're doing these types of work whole number hours or half number hours. Let's use whole number hours. So I need to go 354 divided by 25. So 25 goes into 35 once. Drop down the 4. 25 goes into 104 4 times. Now, the reason why we want to round up is because we need to make at least $354. So whatever this decimal is, wouldn't be that hard to figure out for this one, but whatever it is, I know I'm going to want to round up. So X is at least 15 hours. Now I just realized I ran out of room, so let me clean this up a little bit. So I have enough room to do part B. Now for part B, we're not worried about the number of hours worked because we're given that as 80 hours. But we're wondering how many days can she stay. So the number of days is, and since I used X in part A, I'll use Y in part B. So just like with part A, I can't do this right away. The first thing I'm going to figure out is how much money does she have. So total saved. Well, that will be the 550 she started with plus 80 times 25 hours per hour. And that comes out to 2,550. Well, now that's the total money she has saved. Her total cost, which we did before, which was 279 plus 300 plus 65 times 5. But that's when we knew we were staying 5 days. This will be 65Y. Well, this time, because this is the cost, not how much we need to save up, this has to be less than or equal to the 2550. So we go ahead and solve for Y. We get, well, let's add like terms first. So we get 579 plus 65Y less than or equal to 2550. Subtract 579. That gives us 1971. Divide by 65. Divide by 65. And we get Y is less than or equal to 1971 divided by 65. Let me make all this just a little bit smaller. And just like with the previous part, we do need to get the decimal for this. So we go 1971 divided by 65. 65 can't go into 1, can't go into 19, but it can go into 197 3 times. Subtract 2, drop the 1. 65 can't go into 21, so we get 30. And this would be a decimal, so 30.4, let's say. So since I have to be less than or equal to 30.4, that means Y is at most 30 days. And that's how you do example 6. Okay, just 2 more examples for this video. So example 7. One number is 7 less than the other. Their sum is 19. Find the numbers. So here we have one number. Let's call that X. And then we have a second number. Now, since I know their sum is 19, if the first number is X, the second number would have to be 19 minus X. That way, when I add them together, we get X. So now, after coming up with that, I'm going to use this to come up with my equation. It says one number, so X, is means equal to 7 less than the other. Remember, less than means we're going to subtract 7. So this is 19 minus X minus 7. Because this is the other number, and this means 7 less than. Okay, well, 19 minus 7, that'll be 12 minus X. Let's add X to both sides. So we get 2X equals 12. Divide by 2. Divide by 2. X is 6. Now, don't think you're done after you solved for x, because it says find the numbers. So we do have to find both of them. So the first number is 6. Well, the second number is 19 minus that, so 13. And that's it for example 7. Now, example 8. The sum of two consecutive integers is negative 187. Find the integers. Well, now we have consecutive integers, and we have two of them. So for the first integer, let's call that x. Since the second integer is the consecutive integer, that means one more, that'll be x plus 1. I'm going to go on a little side note here. Newton will give you some that say two consecutive odd integers sometimes. So like 5 and 7 or 13 and 15. Well, odd integers are always 2 apart. So instead of x and x plus 1, you would do x and x plus 2. Similarly, they might say two consecutive even integers. Now, a lot of people think it has to be different than odd, but it isn't. Just like how odd numbers are 2 apart, even numbers are also 2 apart. So if you have two consecutive even integers, it'd be x and x plus 2. But for this one, because it doesn't use the word even or odd, it's x and x plus 1. Now what this says is the sum of those, so x plus 1, is negative 187. So then we get 2x plus 1 is negative 187. Subtract 1, subtract 1. 2x is negative 188. And then divide by 2 on both sides. So x is negative 94. So if x is negative 94, the second integer, because again it's asking for both, is 1 more than that. Don't make the mistake of saying negative 95 though, because it's negative 94 plus 1 becomes bigger, so it's negative 93. And that is it for section 3.1.